This problem states that helium at 200 kPa and 20 degrees C is heated by mixing it with argon at 200 kPa and 500 degrees C in an adiabatic chamber, which means no heat transfer occurs. Helium enters the chamber at 2 kg per second and the argon enters at 0.5 kg per second. And then the mixture leaves at the same pressure. So it asks us to determine the final temperature and the rate of entropy generation, which is S dot gen. So we'll go to test calcs, flow states. We're going to use the PG plus PG model. And we'll start entering our known properties. So we know that the first fluid is helium, so we'll scroll down for fluid A, get helium, and the second one is argon, which is right there. And so the first fluid is going to be pure helium, so for the mass fraction, we'll enter 1. And we know that it's at 200 kPa and 20 degrees Celsius. We'll change the units to Celsius. And 2 kg per second. So we have all our properties for state 1. State 2 now is going to be pure argon. So for the mass fraction of A, it's going to be 0. Pressure is still 200 kPa. And the temperature is given as 500 degrees C. And m dot as 0.5 kg per second for the argon. Calculate. Alright, and now state 3 is going to be the mixture. We're told it stays 200 kPa. We know that m dot is going to be m dot 1 plus m dot 2. The mass fraction of A, or fluid A, which is helium, is going to be m dot 1, because that was the helium flow, divided by m dot 1 plus m dot 2. Calculate. And since it didn't fill out all the properties, obviously we still need to enter some more. One other thing that we know is that volume is an additive property, so we can do volume dot 1, or 3 gets volume dot 1 plus volume dot 2. And calculate. Now we have all our properties. So the question asked to find the final temperature of the mixture. So at state 3, we'll keep it in degrees Celsius. So we get that the mixture temperature is 31.7 degrees Celsius. The next problem asked to find the rate of entropy generation, or S dot gen. So I just grabbed this equation from the equation sheet in table J. So we're solving for S dot gen. We know that, or we're just going to assume that it's a steady problem. So ds dt will go to 0. And it's told to be adiabatic, so we know that q dot is going to be 0. So that leaves us with these terms, which we have the m dots, and we calculated the specific entropies. So we can go back to test calcs in the IO panel. And I like to do it in a few lines. You could probably do it all in one line, but I think this just keeps it organized. So S initial will be m dot 1 times S1 plus m dot 2 times S2. I just hit enter, you could hit calculate, and if you scroll down, there's the initial entropy. And then S final is going to be m dot 3 times S3. Enter or calculate, scroll down, there it is. So according to that equation, S dot gen is just going to be the difference in those. So S dot gen gets S final minus S initial. Hit enter or calculate. Scroll down and we see that S.gen is about 0.66 kilowatt per Kelvin.